As an Ansys partner since 1984, we are highly committed to helping you design, simulate, and succeed.
Hello everyone, this is Alex Austin, the structural group lead here at DRD Technology. I'll be talking about static fracture mechanics of an airframe bulkhead beam. The primary objective of this type of simulation is to simulate a static fracture test of said airframe bulkhead beam and determine an appropriate place to put a crack arrestor or a structure that prevents crack growth from that simulation. So the beam in question is what you see here on the left. It is fixed at the top and bottom, and then we have a single pressure load on the back side of about 1 megapascal, and we have a surface that overlaps the solid, and this tells the software where the crack is located. So at the end of this line right here is where the crack is located in the structure. Now, how does Ansys solve crack growth simulations? Ansys by default solves crack growth simulations by using the maximum tangential stress criterion, and basically this is a way that Ansys calculates stress in front of the crack. It calculates the angle of that maximum stress to determine the growth direction of the crack, and then determines the stress intensity factor, K, which is then compared to the material data that you provide to determine if the crack will grow or not. Now, within simulation, the way this works is you tell the simulation how many times you want the calculation to be completed, and Ansys will start growing the crack, in this instance from left to right, one element at a time, comparing that stress intensity factor it calculates to the material to determine if the crack is going to continue growing in the structure or not. Now, this requires general 3D remeshing that Ansys employs during the simulation. This is entirely hands-off by the user. The solver just handles the remeshing for you. Now, in terms of material data that you need to supply for static crack growth or static fracture, we only consider the upper right-hand portion of the crack growth curve. And this crack growth curve is dependent on a material. So the critical stress intensity factor, or K1C, is all we need for static fracture. And Ansys uses this as a binary switch. If the calculated stress intensity factor in simulation is greater than the critical K1C value, then the crack grows to the next element. If the calculated value is less than the critical value, then the crack arrests and stops growing. So we can account for both growth and crack arrestment in one simulation. For the simulation itself of that beam, we solve this once. We input the critical stress intensity factor. That's just an input field in the software. And then the solver grows the crack in simulation. So if you can see here, this line here, this is the start of the crack. And as the crack grows, you'll notice the direction changes. That's all just part of the simulation, until eventually it gets to this kind of stiffening structure down in the bottom of the beam, and the crack stops. So over the course of the simulation, Ansys is comparing the calculated K value to this critical value, and once the crack grows long enough to that lower structure, stiffening structure, you can see the calculated K on this graph is below the value that we've supplied. Now, since we don't want the crack to grow that far in the structure, we add a stiffening structure or crack arrestment structure to the beam. And this is to prevent the crack from growing nearly as far. And so here you can see the crack grows and grows until it gets to that beam and stops. And we see that the same thing, where once the calculated delta K gets below the critical value, the simulation stops growing the crack. Now, for more information on fracture mechanics, we have several webinars and a fracture mechanics training course on our website, which you can find at drd.com/resources and drd.com/training.
Contact us today to discuss your unique physics challenges and find the right Ansys tools for you.